Okay, so we're back to lesson number 2 for the whiz wheel, and that's where I look at how we use it to solve some basic problems. And so one of the problems we're going to use it routinely to solve is what's we call a time, speed, and distance problem. If you know 2 of these, you can solve for the third. So being very simple, if I know that I'm going to drive for 1 hour at a speed of 60 miles an hour, then I can figure out that I'm going to go 60 miles. 60 miles per hour for 1 hour means I've gone 60 miles. Likewise, 60 miles an hour for 2 hours means that I've gone 120 miles. And that's whether you're driving or flying, doesn't matter. So as long as I know 2 of these items, I can figure out the third. The trick is that we don't always use 60 miles an hour. We start to use some very, obscure numbers, 87 miles an hour, 112 miles an hour. These are speeds that the airplane may go, and the math is not as simple then, and that's where the whiz wheel comes in. So let's just use an example of how this works. And what we're going to start with is we're going to look at this arrow right here at 60. Now this will be marked differently on different whiz wheels, but it always works the same. At the 60, and sometimes it doesn't even say 60, but right between 55 and 70, there'll be an arrow. And that arrow, if you notice on this whiz wheel, it says rate, because we refer to this as the rate arrow. So when we say 60 miles per hour, that's a rate. 100 gallons per hour is a rate. Even knots, KTS, knots that we use to measure airplane speeds means nautical miles per hour, and so that would be a rate. How fast are we going per hour? How much are we using per hour? And so that's where we call this the rate arrow. It's set at 60 because there are 60 minutes in an hour, and so that lets us do the math differently. A minute ago we looked at how the 10 works if we were doing regular math, but hours don't use 10 minutes. Hours use 60 minutes, and so that's why we have it set at 60. And so the way we'll start with this is we'll do something fairly simple. We're going to point our rate arrow at a speed. So let's just point it at 90 miles an hour. So we're going 90 miles an hour, and we want to go for, let's say, 90 miles an hour for an hour and a half. That's a good example. So 90 miles an hour for an hour and a half. So I'm going to rotate this middle part to point the rate arrow at our speed, 90 miles an hour. Without turning the middle part now, I'm going to move the whole thing until I can find an hour and a half on the inner ring here. There's my hours here. These are my minutes. So 90 minutes, hour and a half, same thing. And so I'm going to not spin anything. I'm just going to turn the whole thing so I can read it. When I get here, I'm going to go back out. This is my distance ring. Remember, these are always time. Minutes and hours, this is always time. So my answer has to be out here somewhere. And so it turns out that if you go 90 miles an hour for an hour and a half, you're going to go 13.5 miles. Now again, if you were paying attention in the first video, you know that's not the right answer. You can't go 90 miles an hour for over an hour and only go 13.5 miles. That really should be 135 miles. So if this is 130, this is 140. Halfway between them is 135. And so in fact, 90 miles an hour for an hour and a half, you'd go 135 miles. Okay, we'll do one more. And so that will be, let's try a faster airplane. Now we've got an airplane that's going 130 miles an hour, or we'll even use knots. We'll use an aeronautical term. We'll use 130 knots. So how far can that airplane go in 4.5 hours, for example? So at 130 knots, if you've got 4.5 hours of gas, how long or how far can you fly the airplane? So again, we're going to point our rate arrow at 130. Without moving the rate arrow now, we're going to spin the whole thing around until I can find 4.5 hours on the outside, or sorry, the time ring. There it is there. So 4.5 hours, and then we're going to go out to the outside edge. Now in this case, that's not as exact as I might like it as I just look at it, but it's going to give us a pretty close answer. But you can be very precise if you're careful. So if you see here, 430 is there. That goes out to here. That would be exactly 270 minutes. And if we go out to the outside edge, we got to start counting here a little bit. But if this is 55 or 550, that's 560, 570, 580, 585. And so we can go about 587 miles, 587 nautical miles if we go at a speed of 130 knots for 4.5 hours. Okay, that's how that's going to work. So let's try an example here that I'll let you try to work yourself if you've got your whiz wheel with you there. Let's do, let's say we've got a speed. We'll do a little trick here now. We're going to say a slower airplane. We've got a speed of 85 knots. We won't use simple numbers. We've got a speed of 85 knots, and our time is going to be 2 hours and 40 minutes. Okay, and so these are not normal numbers. The math is not easy. So we've got a speed of 85 knots and a time of 2 hours and 40 minutes. I'll give you a second to see if you can work that out on your own. Okay, assuming that you pause the video, let's go back to our whiz wheel and look that up. And so again, we gave a speed of 85 knots. So I need to point the rate arrow at the speed, 85 knots. Now I need to find the time, which was 2 hours and 40 minutes on the hours rings here. So again, spin the whole thing around. Don't just rotate the middle. But I need to find 2 hours and 40 minutes, which is going to be 2.5, 240 right there. And if we come out here to the outside edge, we'll find out that's going to take us 228 nautical miles. So at a speed of 85 for 228. Now what you're going to find there is that's not exactly totally accurate, but it's pretty close. We'll do the math in a calculator here and maybe edit that in, and you can see how it works out. But the whiz wheel is very close. It's close enough to get us a good answer. All right, so again, that's your time, speed, and distance. We'll come back in the next video and look at how we do the other two. This video, we only looked at knowing these two, time and speed, to find distance. We'll come back in the next video and look at the other two options that we can use to solve as well.